Right, we're on chapter 12, section 6, talking about special right triangles today. Before we do get into the actual lesson, though, let's review, and this will help us as we learn about these different types of right triangles. Remember the Pythagorean theorem. What does the Pythagorean theorem say? Well, it says for a right triangle, that's the key, I can find the three sides by doing a squared plus b squared is equal to c squared. A and b are the legs of the triangle, and c is the hypotenuse, which is the length that is across from the right angle. So here's A, here's B. C is going to be the distance of the length of the side of the triangle across from the right angle. So here we go. Let's find these. If A is 3 and B is 4, what is C? Well, if you've got your scratch paper there, we can find A squared plus B squared is equal to C squared. A is 3, B is 4, and C is, we don't know. This is 9 plus 16, which is equal to C squared. Let's bring it up here. 9 plus 16 is 25. Now we're looking for C. We're finding the hypotenuse C. This is c squared, so we need to take the square root of both sides. Whenever we take the square root of both sides, it becomes a positive negative, so that's a positive negative 5 is equal to c. The square root of c squared is just c, but we're talking about a distance right here. We're talking about a length of a hypotenuse. Can you ever have a negative length? No, which is why c is just going to be 5. Go ahead and pause the video now and find the answers to numbers 2, 3, and 5. All right, let's go over the answers. Number 2, what was your hypotenuse? It should be 3 root 2, or 3 times the square root of 2. Again, we've got 3 squared plus 3 squared is equal to c squared. That's 9 plus 9 is equal to c squared. 18 is equal to c squared. Take the square root of both sides. The square root of 18, that has a perfect square in it. 18 can be written as the square root of 9 times 2. So, let's see, c squared, let me get my eraser out here. Sorry, this should be, the square root of c is, the square root of c squared is just c. So c is equal to the square root of 18, but I can break this up. Remember our rule from last chapter, square root of 9 is 3. So c is equal to 3 square root of 2. Number 3, the answer is 4. Notice they gave you the side, one of the legs of the triangle, and then they gave you the hypotenuse. So again, all you're doing is plugging it into your formula. So you're finding A now. A squared plus 4 squared is equal to 4 root 2, and that's squared as well. So that's a squared plus 16 is equal to, what is 4 root 2 times 4 root 2? Well, 4 root 2 times 4 root 2, that's 4 times 4, which is 16. The square root of 2 times the square root of 2 is the square root of 4. A squared plus 16 is equal to, that square root of 4 is 2, so it'd be 16 times 2, which is 32. This is a 6 right there. Get a squared by itself, okay? So a squared, and let's come down here. A squared is equal to, 32 minus 16 is 16. Take the square root of both sides. A is going to be 4. We didn't do number 4, but it is 6. And the answer to number 5 is 5. So again, review the Pythagorean theorem. A squared plus b squared is equal to c squared. Don't forget to square your values. That's a common mistake. All right, here we go. I've got, what kind of triangle is this? Well, they're both right triangles, but even more so than that, it's an isosceles triangle because 2 of the sides are the same length. What do we know about the angles opposite? So the angle opposite of my isosceles congruent sides, the angles that are opposite, these are also congruent as well. How many degrees are in a triangle? 180 degrees, right? Well, we already know, since it's a right triangle, we know that, let's see, the measurement of angle A plus the measurement of angle B plus the measurement of angle C, it all has to add up to 180 degrees, any triangle. We know that the measurement of angle C, though, is 90 degrees, so we can plug that value in. And because this is a right triangle, we know, because this is an isosceles triangle, we know that angle A and angle B have to be congruent to one another, or they have to be the same exact measurement. So angle A and angle B, those are the same exact measurements. Well, I don't know what they are. Let's just call them X. But X is represented as the angle A. X is represented as the angle B as well, too. So can I solve for X? Well, sure. X plus X is 2X. Plus 90 degrees is equal to 180 degrees. Subtract 90 from both sides. Let's cut that out. 2X is equal to 90 degrees. Therefore, these two angles, angle A and angle B, have to measure 45 degrees each. So, if this side and this side are the same, then let's just say that both sides are the equivalent of 1. Could we find what the value of C is? Yes. So here is what we call a 45, 45, 90 degree angle. A 45, 45 right triangle. Okay, this is our first special right triangle that we're going to discuss. Here we go. If each leg, so here are my legs, if each leg of a 45, 45 right triangle is a certain number of units long, so we don't know what the units are right now, we're just saying that it's some unit long. It's got to be a positive number though, something that's greater than 0. Then the hypotenuse is whatever A is times the square root of 2. So again, we have to have a 45, 45, 90 degree angle, which means that we've got a right isosceles triangle. So that's the first thing. This will only work if it's a 45, 45, 90 triangle. If I know what this side is, then I can find not only this other side too, but I can take that numerical value and multiply it by the square root of 2, and it will give me my hypotenuse. Or vice versa. If I know what the hypotenuse is, then I can divide by A, and I can get the other answer too. Let's do some examples. So I've got a 45, 45, 90 degree angle, and I want to know what is the length of the hypotenuse X. Well, remember, the hypotenuse is going to be whatever the leg is times the square root of 2. Therefore, X is going to be 3 times the square root of 2. I can't simplify the square root of 2 anymore. That's your final answer, 3 root 2. What about the legs then? Well, the length of hypotenuse is whatever the leg is times the square root of 2. Well, if I know what the hypotenuse is then, 5 root 2, I can find A by simply dividing. How do you solve for A? I think I said it backwards in the previous one. You divide it by the square root of 2, not divide it by A. Excuse me for that. I made a mistake on the last slide there. So if A times the square root of 2, what is A? A is one of the sides, one of the legs. Multiply that by the square root of 2, you will get the hypotenuse, which it tells us the hypotenuse is 5 root 2. Therefore, how do you find one of the legs? Divide it by the square root of 2. What is 5 root 2 divided by root 2? That is equal to 5, which is what the value of A is. How can you check it? Well, remember, if you have a leg, all right, which is 5, then the hypotenuse is going to be 5 times the square root of 2. Is that what the hypotenuse is? Yes, it is. Why don't you try these? Find the lengths of the legs for number 1 and 2 if you know the hypotenuse to be these two. Remember what we just did. If you need to rewind to go back to the previous slide to remember our formula, how do you find the leg if you know the hypotenuse? Alright, well the hypotenuse is 10 root 2, therefore the legs are 10. Both of them are 10. And then number 2, both of the legs are 3. What about this one? So 8 root 2 is the hypotenuse, and 12 root 2 is the hypotenuse for number 4. What kind of triangle is this? Well, this is an equilateral triangle because, well, it's an acute equilateral because all of the angles are acute angles and all of the sides are the same, so it's an acute equilateral triangle. Notice it's got 60 degrees for each angle, and whatever the sides are going to be the same as well too. Notice what happens when I draw a line straight down and I cut that 60-degree angle in half. So I cut it right in half. What happens when I cut an angle completely in half? Well, that's called bisecting an angle. Therefore, the two new angles you've made are two 30-degree angles. Notice also, if I draw a line perfectly bisecting that 60-degree angle and I draw it all the way down here to the opposite side, I have made perpendicular lines. Do you see the perpendicular lines right here? It's a perpendicular line, therefore I have made a right angle with this opposite side. Well, is this angle right here? I didn't do anything to this one. Therefore, we now have what's called a 30, 60, 90 triangle. Before we were doing 45, 45, 90 triangle. Now we've got a 30, 60, 90 right triangle. And this one also has a very unique, if we have 30, 60, 90 triangles, we have a unique way to find the values of the legs and the hypotenuse. So notice here again we've got a 30, 60, 90 triangle. Again, the 60 degree, we could draw a triangle where the 60 degree is up there and the 30 degree triangle is there. As long as you have a 30, 60, 90 triangle, that will give you the correct answer. All 45, 45 right triangles are, does anybody remember what this symbol is? Similar. All 30, 60, 90, or right triangles are similar as well too. Do you remember? What's the difference between congruent and similar? Remember, congruent has the same shape and the same size. But similar only has the same what? Similar only has the same shape. So, these right triangles, I mean, they're going to be triangles, but are they going to be congruent always? Are they going to be the same size? No, not necessarily. Here we go. 30, 60 right triangles. If the short leg of a 30, 60, 90 30, 60 right triangle is A units long. Okay, how do we know which side is the short side? Take the smallest angle, which is your 30-degree angle, and it's going to be the side opposite. Okay, so the shortest leg, the shortest side of a 30, 60, 90 triangle will always be the side opposite your 30-degree angle. If that is a number of units, again, that A represents a positive number, then the long leg, where's the long leg? The long leg is going to be opposite of your 60-degree triangle. Not talking about your hypotenuse, we're talking about a leg right here. The long leg is going to be whatever the A value is, which was your short leg, times the square root of 3. What about the hypotenuse? Well, the hypotenuse is going to be 2 times whatever the short leg is. These are I don't know if I want to call them formulas, but these are triangles, special triangles that you need to memorize. So again, if we've got a 45 degree triangle right here, we've got A, and A root 2. Now we've got a 30, 60, 90 right triangle, A root 3, and 2A. Make sure the sides are across from the correct angles. All right, let's try an example. Let's find the missing lengths, X and Y, in the triangle. So I've got 2 missing lengths, X and Y. Well, first off, I need to look at my triangle. Okay, it's a 30, 60, 90 right triangle. 30, 60, 90 triangle. Okay. Let's find which one is the shortest side and shortest leg and which one's the longest leg. Well, here's my 30-degree angle. The side opposite of that one is going to be my shortest side. So 4 is represented as my A value. Again, if you need to go back here to the original, we've got A root 3, and 2A. So 4 is my A value because it's the shortest leg. Therefore, what is Y going to be? What will Y be? Well, Y, remember, is whatever A is times the square root of 3. Well, A is 4, so Y is going to be 4 root 3. Again, it's the longest leg, and whatever A is, which is 4, it's going to be that times the square root of 3. What about the hypotenuse? Well, the hypotenuse is 2 times whatever A is, so therefore 2 times 4 is 8 units. Again, the length of the long leg is whatever A is times the square root of 3. The hypotenuse is 2 times whatever A is. Oops. Now we're going to find what the short leg is if we know that I have a 30, 60, 90 triangle. Be a good idea to draw this. Alright, here's my 30 degree, my 60 degree, and there's my 90 degree angle. Find the short leg. So what's the short leg? It's the one opposite of your smallest angle, your 30 degree angle, so that's the value of A. And the hypotenuse, we don't know what the hypotenuse is, so I'm just going to label that as H. If you know that the long leg, the side opposite of 60 degrees, is 6 root 3. How do we find A? Well, remember, to go from A to the long leg, we had to multiply it by the square root of 3. Therefore, what is A? Well, A is going to be 6. Because 6 times root 3 would give me 6 root 3, which is the side opposite the 60 degree angle. Now what's my hypotenuse? My hypotenuse is 2 times A. We just found what A is, so my hypotenuse is 12. Now let's find the long leg and the short leg if we know what the hypotenuse is. Which one do you think we're probably going to need to find first? I would say find the short leg first. So again, let me draw my example here. I know that the hypotenuse is 9. I don't know what the long leg is, and I don't know what the short leg is. But I do know that this is 2 times whatever A is. Therefore, A has to be what? 9 divided by 2, which would be 4.5. Or you can leave it as 9 over 2. That works. So find A first. If the hypotenuse is 2A, is equal to 9. Therefore, divide both sides by 2. You can find A, 4.5. Now, how do you find the long leg? Well, I have to take 4.5 and multiply it by the square root of 3. So a couple different ways that you could write your answer. 4.5 times the square root of 3, or you could keep it as an improper fraction of 9 over 2 times the square root of 3. You don't have to find it as a final decimal. All right, you try this one on your own. Find the missing 2 sides. So pause the video and you figure it out. Okay, did you get x is 5? This is the long leg, therefore the short leg is going to be 5 root 3 divided by the square root of 3. And y would be 5 times 2, which is 10. Pause the video and figure these out. Okay, number 2, x is 6 because this is the small side. The small side, the small leg is going to be, the hypotenuse is going to be 3 times 2. What about y then? Well, 3 times the square root of 3. And number 3, x is 4 because it's the short side, so 8 divided by 2 would give you the small leg, and then 4 root 3 is your y value. All right, I will be on the next video doing example problems.